All right, here we are. This is the lecture for the final review, the things that you'll need to know on the final exam. I'll make it pretty brief, and you're not going to need to do any math. That's important, right? And again, this is only for the last half of the semester. So modules 5, 6, 7, and 8 are what we're looking at. So one of the things that you're going to have to deal with is the traverse. If you remember that, the horizontal control traverse. You need to know what types of traverse there are, whether it's an open traverse or closed traverse, and how those types of traverses begin and end, whether they're on known control points or unknown control points. Also, you want to know the order with which traverse is done. What's the order of taking field measurements, publishing coordinates, balancing your field measurements, or establishing the control to start with? Whatever the order is, those are the types of things that you'll need to understand and realize. And there's a question about that. So I'm telling you, you need to understand the order of how the components of a traverse work from start to finish. Uh, Something else, and again, everything is going to pretty much be from the book. I don't think there's anything in here that is directly from a lecture. The one of the things that you need to also keep in mind is that the quiz or final exam is going to be random. In other words, the order is going to be random. It's going to be scattered all throughout the book, and you're going to have to work with that, but you'll have plenty of time. One of the things that the book did talk about was, with regards to your traverses, was uh, the methods of balancing the data. And I will tell you that regardless of what the book says, I'm telling you what you need to remember is that in the state of Maryland, we use least squares method. The book talks about other methods, compass and a variety of different methods, but we're going to be using a least squares method for traverse closure because we're in the state of Maryland, and that's generally what is required by the state of Maryland for minimum standards of surveying. So that's not going to be completely in the book, but that's going to be what you're looking for. The other thing as we move from traverse is, remember we were dealing with um, real-time kinematic surveys, or RTK, satellite receivers. So you're going to want to know a little bit about the satellite receivers and GPS receivers. Uh, I mean, some basic things of why it's important. I'm not going to ask you about wavelengths or anything like that. I'm not going to ask you about satellite geometry. We're going to be talking about general principles. And so why is GPS important today? It's not an essay question like I'd have given you an assignment, but there's some multiple choice, and you'll need to pick the best one. Um, so let me see. I'm just sort of scanning through the test right now. All right, and then what's some other stuff? Know about geomatics and the definition of geomatics. You probably want to know about reference stations. What are reference stations? The things that we have that will utilize the internet and transmit signals that are from a reference station to your base station that you're working on your pole or on your site. You want to know about those types of things. Um, let's see. I said you want to know the definitions of geomatics, and you want to know what the purpose behind geomatics is, and some other things. We talk a little bit about instruments. You want to know what surveyors use today as instruments. You know, there's a variety of ways to collect data with a high for geomatics and GIS surveying. So you're looking at different tools that we would use. We use a lot of different things. You got GPS receivers, you got total stations, you got scanners, you've got sonar, you've got aerial photos with from airplanes. You got a lot of different things that are utilized for measuring devices or measuring survey data that's put inside of GIS, which is all part of geomatics. So you want to know the various tools that are utilized and what tools might not be utilized anymore. There's stuff that's no longer doesn't do the same thing as it once did for us. Oh, let's see. Know about know a little bit about how we have to flatten the Earth and what that's called. You know, we take this round Earth and we project it onto a flat plane so that we can survey with it and, you know, not have to deal with the curvature of the Earth very much. We let the model that places it on a flat plane handle the curvature of the Earth. So you want to know a little bit about that and how each state is unique in their flat plane that they use. Let's see. Again, dealing with like horizontal control surveys. You know what the purpose again of the GPS receiver is and why it's important in the horizontal control survey. Realize that GPS receivers give you very accurate results when used properly. They give you very accurate results in a very short time, and that's the things that you need to start your horizontal control surveys with. Let's see. One of the things that the book talked about slightly, and I don't know that I talked about it in the lecture or not, but with the Maryland minimum standards of surveying, and it's why it's done in a least squares adjustment. But you need to know that that is the accuracy. What's the maximum allowable error under the ALTA ACSM survey standards for the state of Maryland? And it's 0.07 feet plus or minus 50 parts per million, or plus 50 parts per million. Uh, you know, that's what we shoot for. It's it, it's a very tight window for how accurate something can be. And so that's something that I know is not necessarily in the book, but I covered it in a lecture, and I just wanted to remind you that we work at plus or minus 0.07 feet, plus 50 parts per million. And so you'll need to know something about that. Let's see, we talked a little bit about machine guidance. So realize what machine guidance is doing. It's utilizing, you know, GPS and computer programs and models of a site to control and handle, um, you know, equipment, whether that's an excavator, a pan, a paving machine, a bulldozer, those types of things are utilized. The the machine control with the GPS receivers attached to the machines. Once we got past some of that control layout and we got past some of the machine control things with the GPS and your state plane coordinate systems, we also then moved into the curves. And so horizontal curves and vertical curves, you know, you need to know about them. Let's see here. Some of the things you'll need to know are what what are the types of horizontal curves. Um, you know, we've got the compound, complex. I'm sorry, not complex. We've got compound, spiral curves, reverse curves, regular curve. So we have a lot of different types of curves. You need to know what those all are. Let's see, what are some types of things? We did talk about spiral curves a little bit as far as having a smoother transaction and helping to keep railroads on track. So railroads utilize spiral curves, which is an ever-changing radius to pull the train toward the center of the tracks, keep it on the tracks instead of the centrifugal force allowing it to fly off the rails, so to speak, literally. Know about vertical curves and what they're for, whether they're, vertical curves and what they're a smooth transition, for hills and keep you from having to come to a complete stop at the top of a hill and then your bottom of your car, um, you know, hit the bottom of your car as you come over the hill because nobody made it smooth. Also, it helps you to keep your speed up with a vertical curve. If not, think about your bumper would be if you went too fast and you didn't have a good curve, it'd be like driving into a ditch and your front bumper would smash into the front of the other side of the ditch and does nobody any good. So vertical curves and their purpose, same thing with horizontal curves and the smooth transitions that they make. Then we get into some of the highway stakeout information that was done. Some of the things that surveyors utilize to stake out highways. Um, one of the things that talking about it actually tells you to go look at the cross section. One of my questions is about cross sections, and it tells you to go look on page 416 of your textbook to help you answer the question. So I specifically put you to a point in the book to look at a diagram and answer a question. So that's a little bit easier for you than trying to figure it out on your own completely. Also, just general questions about how construction surveyors lay out buildings, whether we're using on the first floor or multiple buildings, and whether we're looking to lay out new control for steel columns or, any of those type of things that might be asked that we went over here just this past module. Also, one of the things that you look for, we talked about estimators. We didn't really specifically mention estimators, but estimators are people that, again, estimate the quantity and the cost of a project. And if they were utilizing, trying to estimate the construction cost of a road or of a building, of a site, what are some of the things that they would utilize in construction, or utilize from the plans to help them figure out the cost, and particularly doing a road. And then again, we'll also talk a little bit, we got another question or two about the as-built surveys and what the purpose of those might be. And that is again to compare, compare the constructed improvements to the proposed plan and verify those. And again, you'll be talking a little bit, a couple questions maybe about the as-built surveys. So I sort of walk you down through the chapters that we worked on. The test is a little bit heavy on the traverse control because that ties in your GPS, it ties in with GIS and geomatics. We'll get a little bit lighter on the back end of the book where we're talking about construction layout and buildings and roads and as-built surveys. So that's it. I will have an office hours this Wednesday, and that is Wednesday the 5th. Yes, I'm gonna have Wednesday the 5th at 8 o'clock, and I will be sending out a invitation for that meeting too. I don't think I've done it yet. But if you have any other questions, I can't tell you too much more about the final, but if you have any questions, I will gladly answer them Wednesday during office hours. So good luck, everybody. I think you will all be just fine.